Okay, good morning, good afternoon, good evening, depending on when you're listening to this voice message and this training slide. Okay, we've been going through the Cisco Network Academy IT Essentials training course. We've looked at Module 1 up till Module 12, and this is going to be the second to the last module, which is security. Most of us in this room are taking the cybersecurity module, which involves very basic introduction to cybersecurity, web security, digital forensic, of course, these IT essentials, then cyber breach investigation. So, but for this module, which is IT essentials, we want to just lay some basic foundation of security. Don't forget that you can take any of the core cybersecurity modules with us. For instance, we have the Cisco Cyber Ops, Cisco Cybersecurity Operations Associate. It's a very comprehensive course that it has about 28 modules, very exhaustive. Cisco Cyber Ops. I think we'll be taking that course by next week. So this course is more or less like a preamble to what you have in the Cisco Cyber Ops course. Also, I'll be very brief with respect to this introduction to cybersecurity. So, as IT professionals, there's great importance that we understand some of these basics. Okay, the course starts somewhere about here. What are we going to be looking at? We're going to be looking at security threats. We're going to look at different types of malware. Malware, like we said earlier on, is malicious software. How do we protect against malicious software? What are different types of network attacks? Then you need to understand social engineering. Social engineering actually piggyback on the vulnerability you have in humans and people, trust issue. So people really fall for um, uh, things that have to do with emotions, right? Um, Attackers will look at that weakness in people and try to exploit that. Then we look at security procedures, what a security policy is, and you have different types of security policies. You have network policy, you have email policy, you have maybe a cyber breach policy, you have password policy, you have several types of policy that should help guide a company's or your IT infrastructure. And that policy can either be prudent, it then means you are not losing your guard, you're trying to allow some things and disallow some things. It can also be paranoid, where you are disallowing most of the access people are going to have to IT infrastructure. And it can also be promiscuous. So these are the three main classes of how you can deploy your policy: promiscuous, paranoid, and prudent. Then you need to understand that physical security measures are very critical and very important, because even if you have the best servers, you have the best routers, switches with the best access control and configuration implemented, you have the best software, you have the best whatever, even you have the best people in terms of IT security. If you don't guide against physical access to your IT infrastructure, to your gadget, to where you have your data, your storage room, your data room, you're going to become vulnerable. So things like your access control, your doors, your even something like if you want to have a kind of security that is not just humans. For instance, barbed wire or this wire gaze that you have around the fence, or you have cameras. All of these things are physical security measures to protect your data. And how do you destroy data? Since we know that most of the times when you just uh, delete files from a hard disk, it doesn't mean that on the disk it's gone off. No, what happens is that just that part is cancelled as data not written, but through data carving, hard disk carving, most of those information that can be gotten out through forensics. Okay, so we're going to look at securing the Windows workstation. There are several things we can do to secure that. We talk about wireless security. We talk about troubleshooting, which we've been seeing in uh, most of the modules we've considered in this information technology essentials course. So the first one is security threats. So, like I said earlier on, there are several sources of malwares. User visiting an infected website. That's why if you have an antivirus or anti-malware program, uh, it will help you even when you are not sure of the particular website you are visiting. It will alert you and stop you from visiting the website if it sees and senses and through scan understand that that website is a vulnerable website. So you have softwares like AVG, ESET, Kapasky, and several other tools. Like I said earlier on in the other module, we deploy antivirus solutions as in thousands, in hundreds, no matter the quantity. So if you want to protect your IT infrastructure, do well to get to us. Users have users has outdated antivirus. So it's not just good to just have an antivirus software. You need to always update it. Web browser not patched for new vulnerabilities. Web browsers have been known to be susceptible to attacks. So these are several ways that you can have a malware attack. So you want to be careful about this. Go through this and take your notes. The greatest and most common threat for computers and the data contained on them is malware. Yes, malicious software is typically installed on the computer without user knowledge. Once the host is infested or infected, the malware could do all of these things. So these are what we call indicators of compromise. When your computer configuration have changed without your knowledge, without you doing anything, when you see your files are being corrupted or your hard disk corrupted, when you see that your information is being collected and stored elsewhere without your consent, where you have extra windows or you have your browsers opening without you doing anything. So these are all indicators of compromise. So you call that indicators of compromise. Let me write that. Indication of compromise. Okay, virus versus Trojan. So what I want you to do is that you have different types of malware. It will do you well to just take your notes and classify all of the malwares according to their name, how they operate, how they spread, uh, their characteristics or the indicators of compromise associated with that type of malware, and some of the countermeasures you have for them. So that way you're able to classify, understand the difference between virus, Trojan, spyware, ransomware, and the rest. So you see them here. So these are the types of malware. So you understand them by how they operate and most of the times their goals. Adware display unsolicited advertising using pop-up browser windows, new toolbars, or unexpected redirected to a web page or to a different website. For instance, I said something about this malware I had sometime in 2007 about a political adware where you just see something like you're working and your browser opens up and it tells you vote for this. It comes up from time to time. So that is a malware, but that the type of malware is called adware. For instance, for ransomware, your files are being encrypted and you're giving up a page, right? And you're told, please pay so amount to a rogue account or a Bitcoin account or somewhere. So if you pay, then your account is being opened up. Most of the times it happens, most of the times it doesn't happen. Same thing with rootkit, spyware, worm. So you're able to differentiate all of these types of malware. Anti-malware program. So you want to make sure that you have your firewall, your Windows security alert system up. It will help you know when you have such kind of infection. So using an antivirus, reputable antivirus software is very critical. I love AVG. You can use Kaspersky, you can use Norton, you can use any of these top. You can just check up top anti-malware programs. There is normally a a checklist, a testing that is done by independent bodies around the world. You have them online, so they say, okay, how each of these anti-malware or antivirus softwares, how they operate, and they are being given scores. So it's important that you use one so that you can protect yourself both for your mobile and for your PC. Signature file update. So each anti-malware company will normally create antis. It's just like when you have maybe a virus. I mean, as people, as humans, if you have a virus or if you have a bacterial infection or you have a uh, whatever type of infection health-wise and you are sick, what the doctors do for you is that they get an anti for that and you take that and you are well. So, but you must take the particular anti for that particular strain of your virus or your bacterial infection or your or fungal infection. So you must take that the particular strain that will counter that. So that's why it's very important for you to make sure that you always update your signature files, right? So when downloading signature files from a Miro, ensure that the Miro site is legitimate site. Always link to the Miro site from the manufacturer's website. Avoid creating too much traffic to a single site. Some manufacturers distribute their signature files for download to multiple download sites. These download sites are called Miros. For instance, I have file A, file B, file C. Sorry, I have file A and I want people to be able to download it. But because of too much traffic for people downloading that particular signature file, I cannot create different rooms where people can have access to it. So the same file, I keep it in several places, so I will not be able to exhaust the bandwidth for each of them, right? New malware is always being developed. Therefore, anti-malware software must be updated regularly. So this process always updated, or rather is always enabled by default. So don't turn off your update. Yes, you might save some internet space and or rather some internet bandwidth, but on the long run it may not do you so much of a good. So make sure that your anti-malware software is always updated. Okay, so you have a video, a short video that you have in your LMS. Please make sure that you listen to it. It's a video demonstration that tells you about virus and threat protection, tells you about firewall, tells you about app and browser control. Because you need to protect yourself against virus and threats. You need to understand that your Windows on its own has a firewall that is built for that purpose. You need to understand that even your browsers have some of these countermeasures inherent in them. So you need to understand how to control them, how to configure them so that you are safe. Even when you don't have an anti-malware software, Windows security can do some little protection for you. So your anti-malware solution is just like an addition to what the Windows security system helps you to achieve. Okay, remediating infected systems. So when you have an infected system, you don't want to have that. So if you have that, most of the times you can roll back, you can do a Windows restore. When a malware protection program detects that a computer is infected, it removes or quarantines the threat. However, the computer is mostly likely at risk. So many anti-malware programs can be set to run on start before loading Windows. Removing malware may require that the computer is rebooted in safe mode, right? So you want to ensure you do this if you still have indicators of compromise, right? So you have a short video on your LMS that helps you to be able to understand that process. So please make sure you get into your Network Academy platform and go through this. If you have questions, you could report back to the WhatsApp group for questions and feedback. networks. So most of the times, not just our PC, we're going to have some of these PCs on our network, and our network might be attacked or might be attacked. So there are several things that an attacker is going to do to be able to understand your network properly. Attacker is looking for network information about a target using Google search, whois, and other tools. For instance, if you go to whois.com, you can put a website there. You're going to see the IP address where the website is hosted. If you pick up an IP, you can put it on whois or Shodan. You're able to see some internal IP address, some external IP address, even performing some advanced Google search or using other tools. Attackers initiate a ping sweep. What do you call a ping sweep? For instance, if I say ping 192.168.8.1, that is normally a ping scan. So I'm scanning just that one IP address. But IP version 4 address with a subnet range of between 1, which maybe the server is going to take, up till 255. I'm going to have 192.168.8.1 up till 255. So if I'm scanning the entire range of IP address for that network, that's what you call a ping sweep. So using softwares like Nmap, Superscan, these are softwares that you can use for doing search. What these softwares are going to do for you is that they are going to be able to scan a network. They can tell you the topology of the network. So a few things. They can tell you they can tell you the IP address of all of the systems on the network. They can tell you the open ports and closed ports. So let me put it this way: closed ports. They can tell you the live systems. So we can know how many PCs are up, how many PCs are not up and running. They can tell you, you could plot network diagrams. Then you could have services running. Several things that most of these softwares can help you do. You could install Nmap on your PC and try some of these things out. Right? So attackers run vulnerability scanners like Nipa, Sukana. These tools will now be able to do, even with Nmap or as well for Nmap, be able to do OS fingerprinting. Let me reduce this to, let's say, 12. Yes. Able to do OS fingerprinting. That's to say you can understand the operating system that each of those systems on the network is running. That's why network engineers will always say on the network, on the data. So you don't want anybody to be on your network. You don't want anybody to be on your network, because if somebody comes on your network, of definitely the person is going to be on your data. Attackers can exploit using Metasploit or Core Impact and other tools. So these are the kind of attacks that can happen in your network. All the person does is that he performs a query of the target, initiate a ping sweep, he looks for active IP address on the network, he runs some vulnerability scanners like Nipa, Sukana, then he starts running exploitation tools like Metasploit and the rest. Okay, types of TCP/IP attacks. So you can have a denial of service, you can have distributed denial of service, that is DDoS, you can have DNS poisoning, you can have man-in-the-middle attack. Now, anytime you hear the word denial of service, you are saying that your normal IT infrastructure, you being able to print, you being able to browse, you being able to ping a particular service, you being able to uh, download the file, you being able to do most of the basic functions you should be able to do. If you can't do that again, you call that a denial of service. So the services that you should be able to use as a legitimate user is now not available to you. So denial of service when it comes to cybersecurity most of the times is synonymous to confidential, or rather availability being missing in your CIA triad. You know, in cybersecurity we say confidentiality, integrity, and availability. So once you don't have services available for you, you have been denied service. So denial of service is an attack where the attacker completely overwhelms the target's device with a false request to create a denial of service for legitimate users. So, but before you can say, oh, I have a denial of service, make sure you don't have any problem with your IT infrastructure. Take for instance, a website is down, it's no longer working, people cannot have access to it, people cannot use it. Before you say you have a denial of service attack, make sure that your hosting is not expired. Make sure that somebody did not tamper with something. Make sure that your service is actually up and running. Make sure you don't have a downtime from your ISP or from your or hosting servers. So you have to isolate all of that before you can now say, okay, maybe I have a cybersecurity attack. Whereas when you hear the word distributed denial of service, you're trying to say you have several systems. So instead of just one guy to attack this guy, you are saying attack is coming from this guy, from this guy, from this guy, from this guy. So you have what you call a distributed denial of service. The goal is to overwhelm the target. Of course, you have DNS poisoning, which is domain name server. Every host, either on Windows or any hosting service, or most services, whether it is email, whether it's hosting, whether it's space hosting, they will normally have a domain name server. So it can be poisoned. And this domain name server, it's what interprets, normally on port 53, it's what interprets your your name, converts that to IP address so that you can normally be able to get access to that service. If you go to whois.com and you type your website name or you type your IP address name and you hit search, you're going to see your DNS server. If you go to your command line prompt and you ping your website or you ping an IP, normally you will see a DNS server. So if that is poisoned, it then means that we'll be getting response from a different place instead of where we're supposed to be receiving service from. For instance, if a website called southtechventures.com is hosted on a particular server, that server have an identification, right? It has a name, which you call the domain name. That is the server for that particular where that website is hosted. So if somebody redirect users to somewhere else, so you call that domain name server poison. And of course, man in the middle attack, where somebody can intercept two hosts on a network. You have Mr. A, you have Mr. B, or rather you have Mr. A, you have the internet, somebody is trying to connect to the internet to send information back and forth, and somebody stays in the middle to sniff and to pick information, intercept this communication. uh, this can happen within a server or within a closed system. Okay, that's the type of attack that you have within TCP/IP. So why we say TCP/IP, transmission control protocol and internet protocol, we're trying to say uh, most of the times these things happen on a network. But you've heard me saying websites, servers. The thing is, your website, your mobile phone, all of the gadgets you have most of the time sits on a network, whether you like it or not. So you just have to look at most of these things in the light of networks. So that's why networking is very, very critical when it comes to cybersecurity. Because that your website is actually sitting on a network. Your mobile phone is connected to a mast, and that mast is a network on its own distributing service to your mobile phone, and that mast is connected to a major mast, and that is connected to a particular server point or a control room, and that control room is connected to a network, and that network is connected to a satellite. So everything is all network. So that's why we normally say networking is life. Okay, you have a replay attack, you have a spoofing attack, you have a sync flood attack. Don't forget the three-way handshake. Your networking class will be able to um, help you understand this better. You have the sync, your sync arc, and your acknowledge. That's what you call the three-way handshake. And of course, your replay attack, where the attacker captures or an authenticated packet, alters it, and sends it to the original destination. So this is very similar and a methodology used in a man-in-the-middle attack. And of course, spoofing, when an attacker tries to forge. There are several tools that you can use to do this. And aside this, you also have MAC address spoofing, right? Or MAC cloning. Several tools can help you do that, like Tactinium and several other tools. So these are type of attacks that you have in a network. ZLD Attack. We've looked at this when we did the cybersecurity foundation course. When you have an attack before the uh, vulnerability is being discovered by the vendor, you call that a ZLD attack. For instance, I have a software, I have a hardware, I have an operating system, and people are able to, normally I will release patch, I'll release updates, I'll release countermeasures for that, for the vulnerabilities in that tool from time to time, and inform my customers, and they can download that through their updates. But if I don't get to understand and know about that vulnerability, right, and I am attacked, so you call that a zero-day attack. So no single solution will protect against all your types of attacks. So you want to use the defense in-depth approach. So this is where you have layered system, right? You have countermeasure A, countermeasure B, countermeasure C, countermeasure C. So you patch on all sides to make sure that you are very secure. So no one solution is going to help you fix all of your problems. None. Yeah, social engineering. So here people are being deceived. So this has to do with emotions, right? Uh you're not suspecting that you're going to have an attack. So it relies on the human nature. And because you want to be helpful, you want to assist people, you want to provide information, you want to aid somebody. You don't want somebody to be in a very bad light or in a very bad situation. What do? You aid the person, you assist the person, you help the person. And in doing that, you make yourself vulnerable. Okay, so some of the techniques are pretexting, phishing, spear phishing, spam, something for something. I think that's what we call the quid pro quo. It's a Latin word. Baiting, impersonation, tailgating, shoulder stuffing, surfing, dumpster diving. You throw trash into the bin. You throw trash into. You have your account statement. You have IDs. You have payroll. You have very critical information, and you don't dispose properly. You don't shred. You're going to have some of these attacks possible. So, how do you do this? How do you protect? You always report suspicious individuals. Never reuse work-related password. I've worked in a consultant for a company where because they want to make sure that all the passwords for the operating systems they have across the server is very hard to guess. So they have it on a paper, on a sheet. So the system admin will always come and enter into the password for anybody that needs to work on the system. But the question is, what happens to that sheet of paper? Normally, after some time, it gets dirty. You want to throw it away. If you throw away, do you now tend to change all of the password again? And even if you throw it away and you've changed the password, it tells about how many pieces you have. It tells about the names of each of the pieces and whatever, and that can be used against you with respect to social engineering. Security procedures. So you have policies. So you have different types of policies. So a policy is just a set of security objectives that ensure that all of your IT infrastructure is protected. And the documents should always be reviewed from time to time. HR, top management should have buy-ins. They should have, you should seek their help, you should seek their assistance, you should seek their approval, because you cannot do a policy as an IT personnel and it doesn't have the acceptance of everyone. Then the staff needs to be trained. You need to train everyone. People need to accept, people need to sign the policy and agree to comply by that policy, because most policies are also going to have punishments if you go against the policy, or if you go against most of those things. Then usually created by a committee with members consist of management and IT staff. So don't just do it alone. If you do it alone, then it might not be binding on everybody. So you have several types: AUP, remote access policies, network maintenance policies, and incident handling policies. So these are the different types and what they constitute. You could check up on Google and say network policy, bank, file type, PDF, right? And you'll be able to download several policy samples for your study, right? You could also say network maintenance policy, bank. You could change these words interchangeably. You could say bank, you could say school, you could say company, you could say church, you could say mosques, you could say you could just change all of this for different types of if companies, different types of niche, different types of situations, right? You could change the policy name, password policy, identification and authentication policy. Then, of course, you're saying file type PDF or file type PPT, because most of those files are going to come in PDF, or file type DOC or file type DOCX, that is docx, that is Microsoft Word document. So if you put this on Google, you're going to see several samples. You could download them, study them. It will help you understand what the content of some of these policies can be. And for most of us doing cybersecurity, these are some one of the first point of call for a cybersecurity expert. So most of the times when I come into a complex, come into a company, come into try to start up providing security for a particular IT infrastructure or for a company, one of the first things I ask is that, do you have an information security policy document? So an information security policy document is going to encompass all of these policies. For a very big organization, you can have this as different documents, right? You could have this as different documents. But if it's a mid-sized company with less than 100 staff, you can put all of these things together into one single document. For instance, for password policies, how frequently should this password be changed? What is the minimum requirement? And all of the rest. So, because no matter what you do as cybersecurity experts, professionals, if you don't have a policy on ground, if you don't have best standards, best rules, how should things be done? If you don't have that in place, then anything you're going to do is not going to last. It's not going to uh, uh, be taken so serious, because it does not have management, it does not have HR, it does not even have the sign off from the employees. Yes, physical security, like I said earlier on, access control, cameras, conventional lock, deadbolt lock, electronic lock, document-based lock. All of these things are things you should consider when securing your IT infrastructure. Like I said, also you can, if you have the best antivirus, if you have the best lock in terms of soft lock, if you have the best PC, if you have the best network, if you have the best whatever you have, if you don't protect all of these gadgets through physical means, right? You you even if uh, your attacker don't actually break through into your system, mere taking away your system will cause business discontinuity. So your business continuity is affected when your attacker takes away your system, and that's compromise. You're not going to work for that day, for that week, and you start talking about backup and the rest. So you want to make sure that you physically guide and guard your IT infrastructure. Okay, man traps, you have cabling, you have your data is your greatest asset. So we normally see on the network, on the data. So if your data is stolen, if your data is compromised, it can lead to so many things. Data is likely to be an organization's most valuable asset because you can have data worth $1 billion and all your gadgets, all your hardwares, all your software license, everything put together might not even be up to $100 million. So data is very, very critical. Then you should look at seeing that you guide and guard your or rather you guard your data. Data backup is very important. File permission, files and folder permission. Uh, who should have access? Who should have full access? I've explained this in previous module. Database administrators and web developers to talk about the CRUD operations: create, read, update, delete. Who should be able to create? Who should be able to read a file? Who should be able to update a file? Not everybody that is reading a file should be able to write a file or create a file. Not everybody reading a file should be able to update or modify the file. And we should have full control of the file. So it should be very critical about that. And there's what we call the principle of least privilege. So only give people privilege that they need. And when somebody changes his desk, changes his work area, changes his department, make sure that he does not transfer such privileges he had earlier on into the next office. Make sure you revoke such privileges before he gets to his new workplace. Else, he's going to accumulate all the privileges he has across all the different departments. And before you know, he's now having quite a huge number of privileges. Okay, folder encryption, we've talked about this in previous module. So you want to look at this video demonstration. It explains how to encrypt a drive, the options you have for instance, for Windows BitLocker. So data wiping. So there are different ways you can do that. If you want to wipe data, if you want to wipe access to from your hard disk, from your flash drive, you can use data wiping software, you can use degassing, you can use electromagnetic degassing device. So these are the different ways you could take off data completely from your device. Okay, recycling. So securing. So we have we have to look at securing our PC from different aspects. BIOS. This is upon boot. BIOS is basic input output system. So that's what helps you to do your normal post test. That is your power on self test. So these are your system startup at your system boot up. So prevent the operating system from booting and changing BIOS settings. So you want to secure this, of course, at your login area, then of course at your network layer. You want to make sure you are protected all through. So it's something like this. If you log into, depending on the system, I've talked about this in several of the modules. It can be F2, it can be F10, it can be any of the combination of the buttons on your PC. While your system is booting, you come into BIOS, you can set up a password for it. So if somebody does not have access to this password, he cannot even enter into the PC, right? Then of course your main Windows login. Then these are some of the things you should have in your password policy, a minimum length. So the longer the better, right? But you should make sure that it has some complexity and some variety. And you want to make sure that you have expiry date for most of these passwords you are using. So these are the things you are going to put in your password policy to make sure that people don't just use passwords, they change it frequently. And most platforms are going to be able to tell you if, especially for web platforms, are going to tell you that, they're going to tell you if the password you changed from is an old password. So they kind of keep history of even all of the old password, of course, in hashed format, not in plain text format. Windows local security policy. These are very straightforward items. I think so. You also have maintaining your account. Um, you could configure all of this. You can use that in your group policy. You could do this in your group policy. Tell this is Windows Server Administration. Tell how many times people can attempt to log in, how long they are going to be able to do that. Do you have guest access, or do you want to disable it completely? Because you could give somebody guest access and the person can do what we call the privilege escalation, right? The person can change his guest to an admin account or a standard user, especially if you don't have other measures to counter that. Okay, Active Directory, is there anything that's of great importance here? Firewall, very important. Most of the times your firewall is turned on by default. On your PC, make sure that you turn this off. It's going to help protect your PC. The firewall just serves as a bridge between your network and the outside world or outside network. It will prevent undesirable traffic from entering into your internet network. You also have software firewalls, and most of the times your antivirus or anti-malware or your yes anti-malware solutions, they have this, right? You can also deploy a dedicated software firewall. Windows firewall is an example of a software firewall, but you also have hardware firewalls, but they're very, very, very expensive. Okay, web security. For these are for people that are going to go into web security. In our web security training, we exhausted what we call the OWASP, Open Web Application Security Project. So this is what you want to look at if you really want to go into web security. It's a complete and comprehensive framework that looks at 10 areas. So you call it the OWASP Top 10 Open Web Application Security Framework, right? So if you check this and you get to the website, it's an open source project that tells you the 10 ways you could make sure that you harden and you secure any web application that you create. And this is one of my core areas when it comes to cybersecurity. Okay, in private browsing, pop-up blocker, you want to make sure that you don't just allow anything. Go to your browser and configure that. Smart screen filter, ActiveX filtering, restriction settings, all of this you have that in your browser. For instance, for autoplay, you want to make sure that a drive that you have, a flash drive that you have, doesn't just autoplay. And people can use what they call the bootable or the flash drive pen drive kind of attack. So plug and play. So you have there's a script within the flash, within the CD. The person puts it in even while you're away from the PC, while you're away from the laptop. Person plugs it in, it runs, and it can retrieve it. You could try what we call the Chrome password exe. It has a version for I think Firefox also. So this is a very dangerous tool. It's less than 200 kilobytes even. And that is even up to 300 kilobytes. It can run and download all of the passwords that you have saved on that PC with respect to the browser. So you want to be very, very careful in how you allow things to auto run on your PC. So you go to control panel, go to autoplay window, and you can toggle that on and off. Operating system patches, you want to make sure that your system is up to date. But I am very weary when it comes to updating systems. You want to make sure that there's compatibility, right? Compatibility between your hardware and the updates. Because if you make updates that are not compatible with your hardware, you're going to have issues. I've had issues when you see somebody updates a PC and the camera is no longer working. You update a PC and the keyboard is having issue. You make an update and your sound driver, your sound is not working, or your video is not working. So you want to make sure that your hardware is a little bit recent for the updates that you're trying to do. And most of the time, these updates are going to come with security patches, right? it might be protecting several things. You can go to your update history and you're going to see all of the different patches and their descriptions. They are normally coded, so you could research more and see all of the patches that you are getting. So wireless security, you have hashing, symmetric, and asymmetric encryption. So I think I've discussed this extensively with respect to our digital forensic course that we're running. So hashing just does a little bit of encoding. It can be one way, it can be two way. For symmetric encryption, you're talking about, I use the issue of same key to lock to unlock, right? Here you have different key to lock and to unlock. Think about this like when you look at um, animals that you can that have symmetry, right? You could divide by two equal parts: a goat, a cow, a sheep, even humans. We are symmetric beings. That's to say, if you put a knife at the middle of somebody's forehead and you divide all through, what you have on your left is what you have on the right. So that's why you say same key to lock, the same key you use in unlocking. Asymmetric, so different. An animal like an arm weber, right? So these technologies, and of course for MD5 you have MD, rather for hash encoding you have MD5, you hash 256, you have several hashing um, uh, what's it called, encoding algorithms. So I think we're doing a model that is just for encryption, right? So you could study this to understand that most of these wireless devices, they use this to, so that password that you are having, that password you're having, the password you're having is always encrypted, right? So it's not stored in plain text, right? So when you put in your password is 1234. When it goes to the sandbox or where it's being saved, or depending whether it's a network, whether it's a wireless device, whether it's a operating system or a website or wherever, this encryption has application in several fields. That is not being stored in plain text, it's encrypted. So we're saying, how is this accomplished? Is using any of this. So if something is 1234, if it's encrypted, it can become something like this, right? Depending on how many bits, something of this nature. So these are the technologies used in doing that encryption. So encryption is typically, so you have what you call plain text and have what they call ciphertext. So plain text is this 1234, ciphertext is this. So it's just to make sure that even if somebody is sniffing our network, the person does not see this 1234, the person sees this. So there are several ways to also make sure that this thing cannot be reverse engineered back to this. So you call those password sorting and password hashing, and also password peppering. Right? You know pepper used in cooking, yes. You know salt used in cooking, yes. So instead of me to have, if I understand that this is MD5 for SHA-256, for instance, instead of me to know that, okay, because most of the times the methodology is open book, so people should, if they understand this or they understand this, they can see this, for instance, maybe through sniffing or through scanning or through whatever, they will be able to go back to this. But how do you make sure they can't go back to this? Is by adding something to this before you do the encryption, right? Either before or after. So what happens, that's what happens in password salting and peppering. So what happens, just like when you cook your food, you want to add a little salt, you want to add a little pepper, you want to add something so that you have a better taste. So if you try to go back to your original plate of food, you don't have same thing again, right? So if the person takes this and is trying to go back, of course, he's not going to be able to get this. So these are some of the things you need to understand about encryption. So communication between two computers may require secure communication. So these are some of the ways that encryption and security can be done when it comes to your wireless device. Okay, yes, you just have it here. So hashing uses a mathematical function or what we call an algorithm, a formula. So you have SHA, you have MD5. Okay, so symmetric. So confidentiality. This explains to you symmetric. This explains to you asymmetric. All of the things I've been trying to explain earlier on. SSID. That's that name, for instance, that you're going to use in assessing. So you can decide to broadcast it or you can decide not to broadcast it. Authentication method. So what are the different ways that you can authenticate your wireless device? So it can be web, it can be WPA2, WPA, it can be WPA2. So this is a little bit more secured. Whereas this is open, you don't want to have an open wireless system. So you should use any of these technologies. So of course, web and WPA, you could use John the Ripper, you could use Crack NG. There are several tools you can use to break this off. So please be very, very secured. So these are wireless mode. Firmware updates, you want to be very careful. Firewalls, I've talked about that. Port forwarding and port triggering, universal plug and play. So troubleshooting. So like we've talked about earlier on, you want to be able to identify the problem, right? We've talked about this. This is like basic for every of the modules that we've been considering. So you want to make sure that you follow through this to know what your probable costs can be. Do you have a virus? Do you have a Trojan? Do you have a worm? Each is going to have how you're going to solve them, right? So you go through this, take your notes, and if you have any questions, please make sure you ask within the WhatsApp mentorship group. So some of the new words that you've learned in this module is virus, Trojan, adware, ransomware, and all of this other stuff. Okay, thank you very much for listening. That is the end of the module 13, security in the Cisco IT Essentials training course. Thank you very much.